Hello there. In this video we're looking at finding inverse functions for learning intention 20 and 21. So I'm going to combine these two into the one video. I want to look at the process, so I'm going to do it informally in the first example, and then I'm going to be much more formal in the second example. So in the first example, I'm going to ignore some things and just show you the process so you can recall what to do. And then in the second example, I'm going to go over what I ignored and show you all the details. So a question might look at something like this. So consider f of x equals 3e to the x minus 4 plus 1, and it will say find f negative 1, which means find the inverse function. Here's the function. It's asking us to find the inverse function. I'll remind you what this means, but I'll just show you the process first. So the way you do this is you swap x and y and then solve for y. Swap x and y, then solve for y. So here you have y equals 3x minus 4 plus 1. So you swap x and y like that, and then you solve for y. So let's use our algebra. So that's x minus 1 equals 3e to the power of y minus 4. Divide both sides by 3 e to the power of y minus 4. Great. And we know our log laws now. So we're going to take the natural log of both sides. And then we're going to add 4 to both sides. Oh, that 4 looks a bit funny. Let me fix that up. X. Oh, that's not a 4. That's a 1. It's a 1 there. X minus 1 on 3 plus 4. Okay, that's our answer. Suppose you got to use your CAS for this. Show you how you do it on your CAS. So you take this part and you solve for y, just as you do. So you want to get out your solve function, which is menu. Whoops, this is frozen. Let me just open it again and let it boot up. So just like you solve for y here, you can tell your CAS calculator to solve for y, and if we've done it correctly, it should give us the same answer. Let's have a look, see. Alright, so solve is menu 3, 1. So I want to solve x equals 3 times e to the power of y minus 4. Make sure you hit this right arrow over here when you want to move out of the index part, plus 1, and we want to solve this for y. Great. Gives us the same answer. Notice that it has a little domain restriction there, and that's really good that it's put that in, because x has to be greater than 1, because you can't have the natural log of a negative number. So your calculator's done a good thing there. So to be more formal, we'll put that in. But I just wanted to show you the technique. Alright, let's get formal now. So I'll clear this. Now that you know the process, let's be formal. This is for learning intention 20 and 21. So given the function f of x, for the inverse function to exist, f of x must be a one-to-one function. And I'll remind you what a one-to-one function is. So let's draw a set of axes. And let's remind ourselves what one-to-one means. I'm going to sketch a one-to-one function. Here's an example of a one-to-one function. No, not quite actually. There you are, that's a one-to-one function. That's f of x. The reason it's a one-to-one function is it passes the horizontal line test. So I can draw any horizontal line and only hit the curve once. And it passes the vertical line test to say it's a function. So if it passes the horizontal line test and the vertical line test, f of x is one-to-one. And we're happy with it. So to find an inverse function, for it to exist, the original function has to pass these tests. And let's remember what the inverse function actually is. Given the line y equals x, so let's sketch y equals x here. The inverse function is the reflection in the line y equals x. So the inverse function here would look something like this. So if you manage to sneak a ruler into your exam with a mirror on it and put it there, you could literally look into the mirror and see the inverse function. So if the black is f of x, the blue is the inverse function. So it means we might have to restrict the domain to make the inverse exist. I'll show you what I mean with a concrete example. Let's say for y equals x squared, restrict the domain to find the inverse function. Alright, we all know what y equals x squared looks like. But it's not one-to-one because it doesn't pass the horizontal line test. It passes the vertical line test. So let's restrict the domain. Let's define it formally as f of x equals x squared for x is greater than or equal to 0. So we're restricting the domain there, and it means we're only taking this part here. Now it passes the test. It's one-to-one, which is fantastic. So let's find the inverse function. And let's solve for y. Y equals root x. Notice how I don't take the negative root. I'll show you why, because the positive root looks like this. The negative root is that other part, which we've chopped out. So that's the graph of y equals root x, which is great. That's the inverse function of this. And it indeed passes, it is indeed a reflection in the line y equals x. There's the line y equals x. You can see, just like over here, it's a reflection in that line. I hope I've cleared up any misconceptions you might have about this. And if you have been, thank you for watching.